Hubble Space Telescope, and it's called the Hubble Extreme Deep Field, and it combines Hubble telescope observations that were taken over a small patch of sky, and it has over 2 million seconds of exposure time, and it's the deepest look we have into the universe thus far at the time of this video. And this is the region that the Hubble was photographing, and you can see when comparing it to the size of the moon, it is a very tiny portion of the sky. And when you're looking at this photo, there are over 5,500 galaxies, some in which scientists have estimated to be over 13 billion years old. And in this video, we're going to look at the types of galaxies that can be observed, how they're classified, and examples of each type. Welcome to Learn the Sky. My name is Janine, and I'll be your guide as we explore the night sky together, one constellation at a time. Let's begin with the broad definition of what a galaxy is. A galaxy is a system of millions or billions of stars held together by the gravitational attraction between the gas and dust within the galaxy. And they're classified by their shape. And if you look here, these are the two main types of galaxies that we see. There's spirals and elliptical galaxies. However, there are variations of galaxies besides these two categories. And this is Edwin's Hubble fork diagram that it's often referred to because of how the spiral galaxies can branch off depending if they have a bar within their structure or if they're a normal spiral. So let's dig into the different types of spirals and ellipticals. So here we have a spiral-shaped galaxy, an elliptical galaxy, and then I also included irregular since they are fairly common as well. And spiral galaxies, as you can probably guess from the name, they have a spiral pattern and visible component parts. And when we look at these three main components, we have the bulge, which is the center of the galaxy. There's the disk, which are the arms of the galaxy, and then there is the halo. The halo contains older stars. The disk has younger, bluer stars, while the center of the galaxy typically has older stars. You're not observing the halo in this photograph, so I found this one of M104. It's called the Sombrero Galaxy in Virgo, and this area here would be classified as the halo. Here we could see the galactic center and then the disk-like arms, and this is a cool galaxy because we're looking at it edge on. And remember, we classify spiral galaxies based upon their shape. So those two shapes include being a normal spiral or a barred spiral. A barred spiral has that bar structure throughout the center, and then the arms go around the center, where we don't see the barred structure in normal spiral galaxies. There are a ton of photographs out there of spiral galaxies. Here are some of my favorites. The Needle Galaxy, and then this one is so beautiful. You could see the amazing arms coming out from the center, and this is Messier 51. And this image is an optical image, but also combines infrared data, so it allows you to see where the heat in the galaxy is, along with the visible bright areas, such as the core of the galaxy. Our next classification of galaxies include elliptical galaxies. And just like spiral galaxies, they're named after their shape. They look like these fat little fuzzy footballs in some perspectives. And instead of the stars spreading out into a thin disk like in spiral galaxies, the stars wrap completely around the galaxy's heart and move out equally in all directions. So let's look at some of the characteristics of elliptical galaxies. They're spheroidal in shape, and the stars wrap around the galactic core, and they are equal in all directions. They're typically composed of older stars, and we usually don't see any new